100 ml of H2SO4 solution having molarity 1 m and density 1.5 gram per ml. It mixed with 400 ml of water. And calculate final molarity of H2SO4 solution if final density is 1.25 gram per ml. So if you see carefully, this questions is like a dilution technique. This means that 100 ml of H2SO4 and you are dissolving 400 ml of water. The solution is getting dilution. So if you use the dilution technique, so in dilution technique, if you solve this method, so we can use this formula M1 V1 is equal to M2 into V2, because M1 means here moles before the dilution is this one, and moles after dilution will be M2 into V2. So moles will be remain same, but molarity will change. So if you see here molarity ignoring the density, so we can write here molarity is 1 and volume is definitely given 100 ml, so it becomes a millimoles, this ml. And if you calculate M2 and you take the volume 400, volume means 400 plus water and plus 100 ml for H2SO4 is 500. So if you solve here, M2 is equal to, so it will be 100 divided by 500. So you will get answer 0.2 molarity. So if you see carefully, so we have given answer 0.2 molarity over here. But the answer of 0.2 molarity is not correct answer, because why is not correct answer? Because whenever density is given, in that case we should not add this volume. We should not add volume, means these two volumes cannot be added. So we'll use the another technique to solve these questions, method number other technique. So this is not feasible. So what we'll do, so in the first case, initial moles, what is the initial moles in 100 ml? So initial moles will be your nothing but the 100 into 0.1 molarity. That will be initial moles point. If you multiply, this is the 100 by 1000. You can see here. So you will get here 0.1 mole. So to proper there will be millimole. This will be 0.1 mole. So this was the initial moles 0.1 mole of H2SO4 dissolved in the solutions. Now we have to find what is the final volume of the solutions. Now to find the final volume, so in this case we will not add the volume. To find the final volume, we know the density. Density, we already know the density is given 1.25 grams. So we have to find only the mass of the solution. So what is the mass of the solution? Now if you see carefully what is the mass solution. So initially the given here for 1 ml 1.5 gram density. So 1 ml density is 1.5 grams. So if you take 100 ml of that solution, so you will have a density 1.5 gram. And similarly, if you take the water, so water is 400 ml. This is the volume. So for a volume of water is 100 ml, right? And you know the density of water is how much? So at density of water is 1 gram per ml. So if you calculate the mass of the water, so mass of water will be how much? So it will be 100 into 1. So you will get here how much? So you will get here, now see it is get 400 ml. So it will be 400 to 1, it will be 400 gram. So total mass of the solution is 150 and this is 500. So total mass will be your 150 plus 400. So total it will be getting 550 gram. Now we know the density. Density is 1.5 gram for the solution. So we can find volume of solutions will be how much? So that will be it will be your mass is 550 and divided by 1 point, that is 1.25 is the density. This is density given. This is the solution density. From here we will get the volume solutions. Now molarity is equal to what is 0. You can say mole by vol. That is know very well. So what is the mole? So mole will remain same. That is 0.1 mole, right? This is the second molarity. Okay, it's final volume. But the volume solution is this much. So we can write here 550 into 1.25. So this is the in terms of ml. So if you convert in terms of liters, you have to multiply by 1000. So if you multiply with 1000, you will get here 125 by 550. And if you solve it, you will get here 0.227. So if you see carefully, our answer is coming D. So this is our correct answer.